Okay, welcome to this is the week 8 webinar, and we're definitely progressing through the course. And let me talk about the plan today. So today I will start out as always with any questions that you might have. So always happy to answer questions. And then after that, we're going to get into hypothesis tests and confidence intervals, but much more useful than what we did the last couple chapters. And that is to look at a comparison study. And it turns out most studies are comparison studies. And we're in particular in this chapter, we're comparing exactly two things. So it could be before and after kind of study. It could be us versus them kind of study. Lots of different comparison studies. And you want to find out, have we gone up? Have we dropped down? Are we different? Those kind of things. So we're going to start out with a hypothesis test and confidence intervals for the difference between two proportions. So we've already talked about a hypothesis test, and we've already talked about a confidence interval in reverse order, actually, and for a single proportion. But now we're going to say, well, what if we want to compare two different things or different groups? And I'll have an example that is just came out in the news, I think, just yesterday, the day before, something like that I saw. And we'll look at, I like to do new stuff, and we'll look at that. Then we'll look at hypothesis tests and confidence intervals for the difference between two means when you have independent data. And we'll talk about what that means also, because that's one of the hard parts, is to know whether it's independent or dependent. So, but we'll say, well, what if instead of proportions, when it was a yes/no survey question, what if the survey question has numbers as the answers? And we'll find out how to do hypothesis tests and confidence intervals for those. Then we'll do hypothesis tests and confidence intervals for the difference between two means when they're dependent. Okay, and it's one of my favorite examples that I'm going to show you. And the reason is because I made many thousands of dollars on it. And that's always a good thing, at least for me. So I'll explain that, and I'll explain how you guys could do it too. But you have to find the right thing. That's the hard part. So we'll do that. And then finally, we will continue and finish the discussion about Project 2. So last week, we did a Project 2 discussion, but I wasn't able to go into the real details because we hadn't had hypothesis tests and confidence intervals for the difference between two means. Now that we will have it after in an hour or so, then we'll really be able to talk about the details of the project. And you'll be able to really think about what you want to do your project on. So that is the plan today. I want to remind you tomorrow, my office hours are earlier. They're at 10 instead of noon. And that's because my office mate actually is at a conference, and I need to sub for him for his pre-calculus class. So I'm going to be doing that, and that we don't cancel classes here if we don't have to. So that's more important. So my office hours are different. And also a week from today, my office hours will be different also. I got to remember the exact hour, but usually they're at 3, and a week from today, they're going to be at noon. And so that's kind of important also. And that is because, I don't know, if you're from Tahoe, you probably know, especially if you graduated from our high school, there's something called a senior project, where the students have to do a senior project, and then there's community people who judge it. And I'm one of them. So I'm going to be judging at the high school, and should be good. I'm also a mentor for one of the senior project students. So I figured that's important enough that I can move my office hour, a couple hours. So just a reminder that tomorrow and then a week from today, my office hour is going to change a bit. So hopefully you've got that. And remember that my office hours are on the same Zoom link that you're on now. Okay, if you're watching this live, if not, then you can go to the syllabus and you can find that Zoom link. So, and that's it. I have office hours 5 days a week, unless there's a holiday like yesterday. So that is the plan. So the question I have for you, are there any questions? there any questions? I'll be happy to answer questions. And if not, I can move forward. Okay, so it says no questions. Always feel free to ask questions by saying it or pop it in the chat box anytime throughout the webinar, and I'll be happy to answer. Okay, so the best way of explaining the topics today is by examples. So I have an example, and the example is the following. Does a higher percent of Americans this year say that inflation has caused financial hardship compared to last year? Okay, so unless you've been asleep for the last few years, you know that there's inflation now. So the question is, are people having more difficulty in terms of their finances this year because of inflation than they had last year because of inflation? And the good news is that actually Gallup conducted a survey, and they do a good job when they conduct surveys. And they took a look at how people felt about inflation, and they did it last year and they did it this year. So this is a typical kind of comparison study, and what today is all about are comparison studies. So the question is, have things changed from last year to this year? And that's a typical comparison study. There's a lot of others too. In medicine, you do a comparison study often where you say, well, if you give the person the medicine versus you give them a placebo, does the medicine help? And that's another kind of comparison study you'll see, and they compare placebo to the giving. And in particular, that's how COVID worked, by the way. I mentioned it last week, but I didn't get into the details. The way they looked at COVID and decided if the vaccination was working is they got 30,000 volunteers, okay, which is a lot. That's a lot of work to get that many volunteers. And then they had, basically, they gave every volunteer a number, and then they used a computer to randomly generate 15,000 of those 30,000 numbers. And the 15,000 numbers that were picked were given the vaccination. And the other 15,000 were given a shot and told they were getting the vaccination. But they weren't. They were just getting a shot of nothingness, but it felt like they could be getting it. And then they looked, months later and found out if they had COVID or not. Okay, and that's how trials are done. It's a comparison study between two groups. This example is, again, asking people, have you had financial hardship caused because of inflation? Okay, one thing to note is that the survey question, if someone asked you, okay, and I'll have you pop in the chat box. If someone asked you, has inflation caused you financial hardship this year? What would you say? Pop in the chat box. Yeah, notice that the answers are either yes or no. Okay, and I'm seeing both in the chat box, yeses and nos. So that can happen, but you won't, with that survey question, no one's going to say 33. Unless they didn't hear me, they're going to say yes or no. When you have a yes-no survey question, and we had two groups, in this case, it's a group from last year and a group from this year, okay? It could also be two survey questions that are yes, no on the same group, and then it's two groups. You can think of that as the group, the answers, the group of answers for the first question and the group of answers for the second question. So if there's two of these groups at which both of them are yes, no questions, then you can do a comparison study. And what we're going to do is we're going to do exactly what we did last week and the week before. So remember, last week we did hypothesis testing. The week before, we did confidence intervals. So when you're talking about two groups, you can still do hypothesis tests and confidence intervals. So let me go into the details on how this works. So again, the survey was asked, not by me. This was by Gallup poll, actually. And I'll bop it in. Anyone get asked this question? Did they ask you this question, Gallup? I have yet in my 30 years of teaching statistics, no one has ever said yes to were you one of those people that got asked? Okay, but there were 1,013 Americans that were surveyed this year by telephone, and 1,011 were surveyed last year, and these were telephone studies. And again, I mean, the probability of you being one of them is really small, since there's hundreds of millions of people in America. So good luck getting surveyed when I asked you. Okay, but you can imagine this survey. And again, 1,011 out of hundreds of millions of people is a tiny percent, but it's a big enough sample size. Okay, and we talked about that last week. Okay, actually 2 weeks ago, when we looked at big enough sample sizes. And for proportions, usually 1,000 or so is what people want, because that's big enough to have a margin of error small enough. Okay, here's the results of the survey. This year, 61% of those who were surveyed said yes. Okay, last year, 56% of those who were surveyed said yes. Any questions so far? Any questions? Okay, so you might look at this and say, oh, well, look at that. More people this year said last year, so there. More Americans, higher percentage of Americans really think inflation has caused them financial hardship this year than last year. What's wrong with that statement I just said from just what I told you? Any ideas? What's wrong with just saying, hey, 61 is bigger than 56%, therefore, higher percentage of Americans this year say that inflation has caused financial hardship. And what's wrong with that? Because there's definitely something wrong with just saying that from what I just looked at. I don't see you jumping in, so maybe I'll tell you. The issue with what I just said is we just have a little over 1,000 Americans surveyed. That's not even close to the population of all Americans. It does not tell us for sure anything. What we can do is we can say that there is statistically significant evidence. Okay, we might be able to say there's statistically significant evidence that the proportion of all Americans who think inflation has caused them a financial hardship is higher this year than last year. But we can't know for certain about the population because we didn't ask the whole population. But we can see if there's statistically significant evidence. Any questions on that idea? Okay, so now the next step, we had hypothesis testing last week, and it's the same step-by-step process. Okay, the step that you need to do is you need to write out what H naught and H1 are. Okay, H naught is P, I wrote P sub 2023, because that's this year, is equal to P sub 2022, where P is a population proportion. P sub 2023 is a population proportion of all Americans who have had financial hardship because of inflation. where piece of 2022 is a proportion of all Americans who have had financial hardship last year in 2022 because of inflation. Any questions on H0? Okay. H1, I got to change this. Should be greater than. H1 is that the population proportion this year is greater than the population proportion last year. And there's my H1. Any questions on that? And greater than because of the word higher. You always want to look for the keywords or thinking about the keywords. And if it's a higher percent, that means that P 2023 is greater than P 2022. Any questions so far? Okay, so we're going to use a 5% level of significance. And the reason why you would do that in this case is this is very standard kind of, I don't know, sociology, political science type thing. And they always use 5% level of significance. That's the standard. Okay, you could look at the type 1 and type 2 errors and realize they're, neither good, but they're kind of they're just both just as bad. Any questions at all on this idea? Okay, so the next thing, maybe I should not put this in here because I don't want you to see it, is we have to find the p-value. How do you think we're going to find a p-value? What do you think the technique of finding the p-value is? Any ideas? So if we want to find the p-value, what must we do? All right, don't see y'all jumping in. Okay, what we need to do is we need to go to the calculator. Okay, this is definitely not one you do by hand. So I'm going to go to the calculator. Which calculator do you think we want to use? What number? 16? 16 sounds good, except it's got one wrong word, and that's the word A. Do you see? We don't have one proportion because we're doing last year and we're doing this year. Yeah, 19. So two proportions. So we're looking at a confidence interval and a hypothesis test for two proportions, and I just called it two proportions. Any questions on that? Okay, so now it says, all right, for the first sample, what was the sample size? And you want to use the first sample as the kind of left-hand side one. So in our hypothesis, the left-hand side is 2023 in both the null and alternative, and that's our first. So first is the left-hand side, and that's this year. So we have 1,013 Americans this year. And then for the second sample, that's last year, we had 1,011 Americans. Any questions on that so far? Okay, number of successes, we're going to have to do a little work. For the first sample, this year we had 61%, but that's not the number of successes. Any ideas on how to find the number of successes, given that information? Any thoughts? Okay, if I don't see it, well, 61%, the sample size was 1,013. So we have to take 61% of 1,013, and that's the number of people who said yes. So we're going to use a calculator for that. And you go 0.61 times 1013. And then you should round to the nearest whole number, because in proportions, you can't have a fractional number of yes answers. There were 618. Any questions so far? Okay, similarly, if we want to find out the number of successes for the second sample, that's going to be 56% of 1,011. Okay, so 0.56 and 1,011. And yeah, so as you mentioned in the chat, 566.16, but we should round. And when we round, we get 566. Nearest whole number. Any questions on that? Okay. If we look at the hypothesis, we're saying the first is greater than the second. So I'm going to click greater than. The confidence level is going to be 0.95. That's our standard. And again, this is kind of a very standard study. And hit calculate. Any questions at all on getting the p-value and also the confidence interval too? Any questions on that? All right, so now there's our p-value. I think I'll take 4 decimals, 0.0109. Okay. So if we're at a 5% level of significance, 0.0109 is less than 0.05. And we're doing a hypothesis test. When you have a hypothesis test and your p-value is less than the level of significance, do you remember what we get to do? Thoughts? Okay. If the p-value is less than level of significance, you reject the null hypothesis, you accept the alternative hypothesis, and you say, our conclusion is there is statistically significant evidence, okay, to conclude that the population, I want to highlight population, the population proportion of all Americans, even highlight all, because we're really looking at, this is now not the sample anymore. Now we're talking about the entire population this year who think that inflation has caused financial hardship, okay, is larger than the population proportion of all Americans last year who thought that inflation caused financial hardship. Any questions at all on the conclusion? Any questions? Again, very important to understand how to type out this conclusion. And I should mention, this is week 8. 8's an even number. Why is that important? Yeah, you're going to have an exam this week. And by the way, the exam is on chapters 9 and 10. So you're going to have to write out a conclusion like this. It won't be this example, but it'll be a conclusion, and you got to have kind of similar wording. Okay, but I should mention, you also will have to do that with the discussion assignment. Please do not just copy and paste my entry into your entry when you're looking at you're replying to the discussion post. A lot of people did that, and it was really obvious because you use subscripts for the P that were what I wrote that had nothing to do with what you were looking at. So don't just copy and paste without thinking. It's really important that you actually understand this and can type this out in. So be careful about that. So again, you can use the template, but make sure that you refer to everything you're supposed to refer to. Okay, any questions so far? Okay, and the exam is about on hypothesis testing, by the way. That's chapters 9 and 10, which are 1 sample and 2 sample hypothesis tests. Okay, so now, just like last week, not much is changing. We should be able to interpret the p-value. And it's the same template as we had before. Now we just have 2 populations instead of just 1. So we're doing comparison. So we can say if the population proportion of all Americans this year who think that inflation has caused financial hardship is the same as the population proportion of all Americans last year who thought that inflation caused financial hardship. Just note, that's just a restatement of H naught. Okay, so basically we're saying if H naught is true, it's the same template that we had before. So I just restated H naught. Okay, and then I said, and if another survey of 1,000 Americans this year and 1,011 last year, okay, was done, if we conducted that, then there would be a 5% chance. Oh, sorry, there would be a 1% chance. Sorry, this is level significance. There'd be a 5% chance that the new study would lead us to falsely conclude. Notice it's the same template that we had last week. So there'd be a 5% chance the new study would lead us to falsely conclude that, and then you restate H1. The population proportion of Americans this year who think inflation has caused financial hardship is, that should be larger, is larger than the population of all Americans last year who thought inflation caused financial hardship. Any questions at all on interpreting the level of significance? Just let you know, there's no way of doing it in not too many words. It's long. Any questions? Okay. If I want to interpret the p-value, it's the same idea. It starts exactly the same if the population proportion of all Americans this year who think that inflation has caused financial hardship is the same as the population proportion of all Americans last year who thought that inflation has caused financial hardship. And if we surveyed another 1,013 Americans this year and 1,011 last year, then there would be a. So that's exactly the same words as what we had before. Now it changes. 1% chance because the p-value was 0.01 about, or 1%. So there'd be a 1% chance that the new study would result in 5% greater this year than last year. So notice that 61% is 5% more than 56%. That's where that 5% is coming. So there would be a new 5% greater this year than last year's percent of the samples who thought that inflation had caused financial hardship. I guess that should be had. Any questions at all on interpreting the p-value and interpreting the level of significance, or most important is the conclusion? Any questions? Hopefully you're seeing it's very similar to last week. Just now we're comparing two things instead of looking at one thing. Okay, and most all hypothesis test proportions look like this. Now we want to do a confidence interval proportion. Note that the confidence interval, the lower bound is actually pretty close to 0, 0.007 or so. And the upper bound is 0.09. Okay, so that was what the calculator gave us for the confidence interval. So 0.007 to 0.093, I wrote. And now we can interpret, okay, the confidence interval. Remember, we used a 95% confidence level. So with 95% confidence, the population proportion of all Americans who think that inflation has caused financial hardship this year is between 1% and 9% more than the population proportion of all Americans who thought that inflation caused financial hardship last year. Okay, any questions? Any questions on that? By the way, had one of the numbers been negative and one been positive, then we would say it was between that negative number percent less to the positive number percent more. You wouldn't even use a negative number, you just say less and more. But this one didn't have that. Any questions on that? Any questions? Okay, so let's move on to the next example. And here's what I got. So, do single women spend more time cooking than single men? Okay, because that might be something you think is true. You know, and again, you don't know. We can't know about all people. Okay, maybe in the world or in America, whatever your population might be, because there's just too many people to ask. So what you can do is you can do a sample. So, and I did this hypothetically, but you can imagine doing a sample. The 35 single women who were surveyed averaged 58 minutes a day cooking, and their standard deviation was 12 minutes. The 38 single men who were surveyed averaged 46 minutes a day cooking, and their standard deviation was 16 minutes. What can be concluded at the 5% level of significance? Also interpret the 95% confidence interval. How is this one different than the one we just did? What's the main difference? What's the main difference between this one and what we just did? What you're thinking. There's one big difference. Standard deviation is mentioned, and that tells you, that helps you tell what the difference is. But in particular, what is it? Standard deviation is a result of the big difference. All right, if you don't know, let me tell you. This is a quantitative survey question. It's not proportions. This is not proportions. This is the survey question here is how many minutes a day do you spend cooking? And your answer might be, 49 minutes. It's a number. You're not going to say yes. You're not going to say no. You're going to give a number as your answer. And that makes this quantitative. So that's different than when you have a yes-no survey question, which is about proportions. Any questions on that? Okay, so the first thing we need to do is we need to write down what H naught are. So H naught, so this is quantitative. And when you have a quantitative question, then we're talking about means in this class. And the letter for mean is, the population mean is mu. And we're comparing women and men. So we can write mu sub W equals mu sub M. Any questions on that? Because our H naught is that the population mean number of minutes that women cook is equal to the population mean number of minutes that men cook. Okay, any questions on that? Okay, and then from here, do women spend more time cooking than single men? So more is greater than. So H1 is mu sub W is greater than mu sub M. Any questions on that? What do you think we need to do next? What do you think the next step is? Yeah, we can use a calculator. There's something I want to note, though. This is two groups where they're not paired up. This is not husband and wife or boyfriend, girlfriend. This is single women, single men. The first woman has nothing special to do with the first man. Does that make sense? The second woman is not paired up with the second man. It's just a group of women and a group of men. Okay, and when you just have two groups like that, then we're talking about independent data. Okay, so now we get our calculator, and let's go back to the calculator menu. And good. As you mentioned, the calculator we use will be two independent means. Okay, but is it 17 or 18? Okay, say 17, but let's look at it. Do we have the data or do we have statistics? Yeah, we have statistics here. Okay, we don't have data. We don't have the answer that every man said and every woman said. We have the mean and the standard deviation. Those are statistics for the samples. So we're going to go to two independent samples with statistics, which is number 18. And what it asks for is the sample size, the sample mean, and the sample standard deviation. So we go ahead, and for the women, that's the first one. Our sample size is 35. And the sample mean for the woman was 58. And the sample standard deviation for the woman was 12. Okay, the second sample, that's the men. The sample size for the men was 38. The sample mean for the men was 46. And the sample standard deviation for the men was 16. Any questions on that? Okay, if we look at our H1, how to greater than. So we're going to greater. We're going to use a 95%. So I put 0.95 for the confidence level. And I hit calculate. Any questions at all on using the calculator? Okay, if not, we can look at T, that's a test statistic. So it's the same students T distribution that we did last week and the week before. When you have means, then the test statistic will come from the students T distribution. When you have proportions, the test statistic comes from the normal distribution. Okay. Any questions so far? Okay, by the way, is our sample size large enough? Or our sample size is large enough? What do you think? Yeah, they're both over 30. Okay, so 46 is bigger than 30 and 58 is bigger than 30. Note, by the way, with this, it's a lot more work because 62 is the smallest number of people you're going to have to ask. Okay, so if you're doing a difference between two means, it's more work than a single mean. Okay, and I didn't mention the sample size on the last example, but it was 1,013, 1,011. If you multiply that by the proportions that we got, you'll get way over 5. That was 5, not 30. Just note that. Okay, for the very first example. All right, so our p-value is really small, 0.00026. Any questions on that? So there's our p-value. Okay, and then I want to remind you, we talked about this last week. When the p-value is less than 0.01, you can use the word strong in front of statistically significant. That's standard. If the p-value is just between 0.01 and 0.05, then you just say there is statistically significant evidence, but you can't use the word strong. Some of you made that mistake on the discussion post, by the way. Okay. So, but here it really is less than 0.01. So we can say there is strong statistically significant evidence to conclude that the population mean cooking time for single women is greater than the population mean cooking time for single men. Any questions at all on the conclusion? Okay, the confidence interval. We have our lower bound is, I'm going to just round in the nearest minute, it's probably good. 5, and the upper bound is 19. Whoops, we want a 95%. I think the last time I did this, I used 99. So 5 to 19. So now we can interpret the confidence interval. So with 95% confident, the population mean time single woman spent cooking is between 5 minutes and 19 minutes longer than the population mean time men spend cooking. Any questions on this example? Any questions? Okay, this is a very standard way of doing a scientific study where you have statistically significant evidence. Is you do a survey question. If you have 2 groups, you ask both groups and you plot in the calculator, and then you state your conclusion. You find your confidence interval and describe what the confidence interval says. Any questions? Not too bad. Okay, you ready for one of my favorite statistical results I ever got in my life. And the reason I call it my favorite is I made thousands and thousands of dollars on it. Okay. And this is what I always talk about because I'm so like proud of it. So one of the things that I do is I watch the stock market every day. I don't know if you guys watch the stock market, but I watch it every day and I invest. Okay. In fact, well, when I left my house, because that's when I turned it off, I had made over $600 today. It's always a good thing, right? Okay, so even the market went down, but I went up, which is good. That's what I care about. So what I look for, especially if I can find it, and it's not easy to find, is I look for patterns that other people don't see. Okay, and if I can find a pattern that other people don't see, I can make a lot of money on it. Okay, whereas if other people are seeing the pattern, then pattern goes away and no one makes any money, basically. But if I can be the one to find it, that works. So this happened about 4 years ago or so. And that is when Trump was president. Okay. And by the way, I never get into politics telling you who you're supposed to like or not like, but I do talk about history, and that's history. He used to tweet about China all the time. Do you remember that? You may or may not remember it, but he used to just say, be angry at China, and he'd tweet about them. It happened a lot. And what I noticed is that every time he tweeted, the stock market went down. And then in about 2 weeks later, okay, or a week to 2 weeks later, it went back up. And I watched it and I noticed it happening. So the next thing I did is I went and tried to find the stock that seemed to react the most to President Trump's China tweets. And it's funny, the company that I found, now most people know it, but in those days, very few people did, because it was a much smaller company, but it was NVIDIA. Have you heard of it? NVIDIA? They make chips. In fact, they just surpassed $1 trillion in their net worth. They went way up yesterday, actually. Not yesterday, Friday. So they just passed $1 trillion. And I noticed that that stock was very reactant to President Trump's tweet. But again, noticing with your just kind of like the feel of it is not the same thing as really knowing. So then what I did is I collected the data. So I collected the data, and here's what happened with the data, is that for NVIDIA stock on tweet day versus 1 week later. Okay, my sample size was small. Okay, this is one of those where I had to use a small sample size because there weren't 30 times that I could find a tweet from him that, that I can stick in and get data from. It was only a small group. If I waited until there were 30, then he's not president anymore. I can't make money. I wanted to make money. So I had a small sample size, and I looked at the price of NVIDIA on tweet day and a price of NVIDIA 1 week later. And what I wanted to do is I wanted to say, is it statistically significant that the price on tweet day was less than a week later? Because remember that if it is less 1 week later, if it is less and it goes up 1 week later, you want to buy it on tweet day and then sell it a week later and then wait for the next tweet. See how that works? Okay, so this is an example of quantitative data. I think it should be pretty obvious that these are numbers, 122, right, 124. These are all numbers. It's not a yes, no question. It's quantitative data, but it's also dependent data, because you'll notice that 106 and 113 are paired up. Okay, this 113 was exactly 1 week after this 106. This 124 was exactly 1 week after the 110. So these numbers are paired data, this data. Any questions on being able to see that these are paired? Any questions? Okay. Also, I was okay with a 10% level of significance. And the reason why I was okay with a 10% level of significance instead of a 5% level of significance is if I could make money in the stock market 90% of the time, I'm happy. Okay. I lose 10%, I make 90%. Then in the long run, I'm going to make money. Does that make sense? And yeah, sometimes I lose money, but I do make money a lot more often than I lose money. Okay, because I do statistics. Any questions so far? Okay. Do we need to assume that the distributions are normal to continue? What do you think? Do we need to assume the distributions are normal? Yes, we do. Notice the sample sizes are 1, 2, 3, 4, 5, 6. And the second sample size is also, when you have paired data, the sample sizes are always the same. So the sample sizes are 6. So that's not greater than 30. So we definitely have to assume the distributions are normal, which may not be true. But again, I had to go with it because I wanted to make money. I couldn't wait until they're over 30. So I went with it. So then what I did is I wrote down my H naught and I wrote down my H1. So in this case, these are dependent. This is dependent data. When you have dependent data, we can look at the difference between the two, the difference between the pairs. So the first pair difference, second pair difference, third pair difference, fourth pair difference, fifth pair difference, and sixth pair difference. Typically use the letter D for difference. It makes it easy to remember. So instead of saying mu sub tweet day equals mu sub me week later, the way you do it is you say mu sub D, or the mean population mean difference, is equal to 0. Any questions on that? Okay, and H1 is mu sub D is less than 0. Because if you take tweet day and subtract a week later, the idea is a week later is bigger, which means if you take the tweet day minus a week later, you get a negative number. So mu sub D is less than 0 is our H1. Any questions on that? Okay, so now we need to go to the calculator. And I'm going to copy this. So I'm going to go back to the calculator menu. And tell me which calculator I need to do. Okay, it's not 17 because this data is not independent. Yeah, it's 20. This is is a 2 dependent samples with data. Okay. And by the way, as I mentioned, we're getting closer to the end of the class. So you notice we're towards the end. I do this in order by week. So just note that. So I can go to 2 dependent samples with data. And now I got to put in my data. So I copy and I pasted it, and I got to put commas between. And let's go into this one. I'm going to copy this row. And I'm going to paste that one in also. Put commas between. Any questions so far? And let's use a 90% confidence level. Because remember, I don't have to be as confident, because if I'm right 90% of the time, I'm a very good investor. That makes sense? So I'm okay being a little less confident than the standard 95%. And I do want lesson. And I hit calculate. And there we have it. So the test statistic, by the way, was negative 2.8 or so. That's a t again, students' t distribution. The p-value was 0.018. Any questions on getting the p-value? So now, I can state my conclusion. And the conclusion is there is statistically significant evidence to conclude that the population mean price of NVIDIA is higher 1 week after tweet than on the day of the tweet. Okay, by the way, after this conclusion, what do you think I did? What do you think I did after this conclusion? It's important to understand how to use statistics. Any thought? All right, if you don't tell me, I'll tell you. I watch the news every day. And when the news came out with the president's tweet, I went and bought the stock. I waited a week. I sold the stock. Okay. And that lasted about a year. And then after that, it turned out he got impeached, and then he stopped tweeting. So that was the end of that. But hey, and in 1 year, any guess on what percent interest I made? What was my profit? What percent profit? Right. In the bank, you get like maybe, a 2 or 3% right now with inflation. Those days you made like no percent in the bank. Any guess on what my profit was? Not 20%. It was hundreds of percent profit. Okay. I made a lot of money on that. So I was able to, literally make thousands and thousands of dollars because I was making it. Okay. That was bummed when he stopped tweeting. It's like, come on. But that's a way to make money, is if you can find a statistically significant pattern that other people haven't found, do it. Okay. And I do it from time to time. Biden, like I said, I don't talk about good or bad, but unfortunately Biden doesn't tweet, which means I can't make money on his tweets because he doesn't tweet. So I haven't found any patterns with Biden yet that I've made money, but we'll see. I'm still watching. So maybe he'll do something and I'll be able to make money on it. But I recommend it, good way to make money. Any questions on this? Okay. Our confidence interval was negative 13.42 to negative 2.24. I use 2 decimals because that's dollars and cents. Remember, this is money. This is money. So there's the confidence interval. And now we can interpret it. So what we can say is with 90% confidence, the population mean price of NVIDIA goes up by between $2.24 and $13.42 from tweet to 1 week later. Any questions at all on these interpretations or anything about this example? Any questions? Because we've now seen at least one example of each of the 3 types for chapter 10, and that is looking at the difference between 2 proportions, looking at the difference between 2 means when the data you have collected are independent, and looking for the difference between 2 means when the data you have collected are dependent. Those are the 3 types. Any questions? Okay, just a reminder, to have a big enough survey to get statistically significant evidence and not have to make the normality assumption and actually have good data, you have to have over 30 for each. Okay, so that's like a little over 62 or more, I guess, if you have even samples. But to have data, pretty much good data, it turns out you usually have to have over 1,000 for each when you're talking proportions. Okay, and that, by the way, is going to be the reason why you're going to be asked to talk about means and not proportions for your project, because asking you to have over 1,000 data values it was way too hard. In each, that's over 2,000. So instead, I can ask you for means and not feel too guilty. So any questions at all on this content from chapter 10? Okay, if there's no questions, then we'll go to the next thing, which is the secret word. The secret word is two, TWO. Okay, so that way of saying two, because this chapter is all about looking at 2 populations or 2 means. So that's why 2, because it's looking at two things that we're comparing each other on. Okay, whereas the last 2 chapters, we're only doing a single population, right? So a single population mean or a single population proportion. Now we're looking at 2 population proportions or 2 population means. Any questions so far? Okay, so now what I want to do is talk about the project. And I've already kind of shown you, I already talked about the basics of the project, so I'm not going to repeat that. You can always go back and look at last week's webinar, but I want to talk about the details of the project. And again, if you click on project 2, then we'll really be able to understand it. Whereas last week we weren't ready yet. Okay, so let me explain what we're doing. The purpose of project 2 is to use confidence intervals and hypothesis testing to support or show lack of support for a research project. Okay, you must first decide what you are interested in researching, and then design your study, and then collect your data. Okay, also identify a client who will be making decisions based on your results. Next, analyze your data to see what it tells you and whether it supports your hypothesis. Okay, so a couple things to note. First thing is this is very different than project 1. So don't assume that it's the same as project one. It isn't. The focus of this project is the confidence interval and hypothesis testing. That needs to be most of the pages of your project. Okay, whereas project one, the focus was on how you collected your data, the mean, the standard deviation, and the quartiles and the graphs. This one's not. This one's focused on confidence intervals and hypothesis testing. Any questions so far? Okay. Like project one, project two, you're going to have a client, and the client is supposed to be the audience for your project. So your writing should be to your client. Okay, not about your client, but to your client. And everything you write is for your client. So what decisions is your client going to make after seeing all the different things in the confidence interval and all the different things in the hypothesis test? I also want to make a note, especially for the hypothesis test, there's an order at which you do things. Okay, and it's the order at which last week I talked about. First, you come up with your idea. Then you write down your null and alternative hypotheses in symbols, then in words. Then you collect your data. Then before you collect your data, then you look at the type 1 and type 2 errors and see the ramifications of the type 1 and type 2 error. And then based on that, you decide on the level of significance. Then you collect your data. And then after collecting your data, you pop it into the spreadsheet calculator, which was the same calculator as project one, just a different tab on that calculator. I'll show you that in a little bit. Then you look at the results. So you look at your p-value, you look at your test statistic, you decide based on the p-value, do you have statistically significant or statistically insignificant evidence? Okay, there's also the standard error. That's kind of the new stat, and that's something you're gonna have to spend a lot of time on this project, is a standard error, which is not just a standard deviation, that's a standard error. And I'll talk about that more in a bit. Then you look at the p-value. Again, you state, is there statistically significant evidence? Is there insignificant evidence? Which one? What's your client going to do based on that? You could go and revisit the type 1 and type 2 error, because at that point, after you do your study, then only one is pertinent. The other one can't happen. Okay, so you can revisit those. You should be based on the p-value. You can talk about whether or not you should trust the data and how much. Is it like your p-value is close but not close enough? So you still believe it, but you don't have statistically significant evidence. So maybe you need a smaller standard error so that you can have a higher chance of statistically significant evidence. And you can get that by a larger sample size. Or maybe you're just way off and you give up and say, forget it, there's no reason to try again. Okay, now you're not going to try again, but you should say whether you would try again if you had more time. Okay, and similarly, based on the p-value, you could talk about how likely the error would be. Okay, so if your p-value is 0.98, not likely to have a type 2 error, and 0 chance of type 1 error. Okay, if your p-value is say 0.06 and you had, let's say, a level of significance of 0.05, then actually the chance of a type 1 error is pretty big, or type 2 error is pretty big. And you probably would want to do another study. Okay, I like to do the analogy of a soccer game. Imagine you're the coach of a soccer team, and your team is behind 8-1. And there's 15 seconds left in the game. Your player is about to kick the ball, and you think the player is going to actually make the goal, but the other team smacks the player and he pushes him down. The judge doesn't call any penalty. Should you argue and scream at the judge or not? What do you think? No, because you're down 8-1. Yeah, you might have gotten a point and you still be down 8-2. You're going to lose. No reason to scream at the judge. Does that make sense? Okay, because even if the judge changed his mind or her mind, it wouldn't matter. Okay, on the other hand, if instead of down 8-1, what if you were down 8-7? And then the same situation happened. Then should you yell at the judge and tell the judge to look at the video? What do you think? Or the referee, I guess I should call him that judge, sorry. Okay. If you're down 8-7 and you can convince the judge to call the penalty, then you got a good chance of winning. Do you see that? Okay, or at least tying. So then it's worth it. Okay. So if the p-value is 0.9, that's forget it. You're so far down, you're not going to win. You see? No reason to even try to do another study. But if the p-value is 0.06, then you're going to go for another study with a bigger sample size. Do you see how that works? What if you're ahead 8-7 and the same thing happens? Do you yell at the judge? Yeah, again, you don't, because you're ahead 8-7. They didn't call the penalty. Game's over and you won. And you still get to celebrate. Do you see that? So that's if the p-value is 0.04, if the level of significance is 0.05. There's no reason for a bigger study because you've won. And you're able to say, yeah, I have statistically significant evidence. You're good enough. You smile. Someone else could maybe do another study, but you wouldn't. Do you see that? So you should be thinking about those things when you're looking at your p-value. And you're considering, do you think another study would be a good idea with a bigger sample size? Any questions on that? Okay, so you could do a short interpretation of the summary statistics, but only the main ones. So that would be the difference between the two means. That's the biggie. So you're going to be looking at the difference between two means, and you can look at that. Don't go through quartiles and all the other stuff. Just a quick one. But standard error you should do. Okay. And again, you have to do the right study. So in other words, if you have dependent data, then you need to put in, you'd have to look at dependent. If you have independent, you have to use a calculator for independent data. Okay. So as I mentioned, the standard error, you need to go into detail about standard error. You should have a whole paragraph on the standard error. Okay. Any questions on any of this stuff? Okay. A lot of people have trouble with the standard error, and because of that, I created a video on the standard error for you to watch. I'll let you watch it and give you a review of what the standard error is all about. Okay. You should also, in a different paragraph, not the same paragraph or the same page even, talk about the confidence interval for the difference and its interpretation. Do not include the confidence interval while you're talking about the hypothesis test. This is the totally separate things. Okay. The other thing that you must do is you must decide, are you going to be using a 95% a 90% or 99%. That is not based on type 1, type 2 error, because confidence intervals are not hypothesis testing. And hypothesis testing can result in type 1 or type 2 error. Confidence intervals don't. So do not say, I used a 5% level of significance, so therefore I'm going to do a 95% confidence level. That's wrong. Instead, what you should do is you should look at the 95% confidence interval. You should look at the 90% confidence interval. You should look at the 99%. Decide based on the pros and cons of each, which is better for your client. And write about that. Any questions so far? Okay. And you should look at not just the confidence interval as an interval, but you should look at the lower bound of the confidence interval. Based on the lower bound, what decisions will your client make? Then you should look at the upper bound of your confidence interval. Based on the upper bound, what decisions will your client make? Any questions on that? Okay, then you should also say that if you say chose a, let's say a 95% because the 99% would have too wide a margin of error, how big a sample size would you need to use so that you could use a 99% with the same margin of error that you had with your 95? Okay, and there's going to be some calculation to do that. And you might not need help, but you do have a tutor that definitely could help you with that. And Kyle, if you forget how to do it, I'll help you too. It'll show you, make sure you remember. But there's a little bit of algebra to do to come up with that. Okay, this should be a paper, again, for the client, and it should be all about the decisions. So don't just write down the template for each of the things. You can write the template, but then you should have a paragraph talking about how the client is going to use it. And that's important. Okay, so most of your paper is going to be those paragraphs on how your client is going to use each piece of information from the hypothesis test and the confidence interval. Any questions at all on this idea? Okay, so you don't want to make it just read like the homework problems, because those are 1 sentence long or 2 sentences long. These are full paragraphs for the client on the use of everything. Any questions? Okay, just a note, a couple things. And I kind of wrote all these things. I already said all this stuff that's in here. I just didn't scroll down. You should talk about whether you need to make assumptions, which you probably don't. Okay. The only assumption you may have to make is that your study is unbiased. That assumption may be needed. I mean, almost certainly will be. Okay. In terms of this, it's a regular paper, introduction, body, conclusion, just like you're used to. You should talk about at the end, kind of the main point and maybe how further studies could be good. That same old stuff there. Okay. And I'll let you read through all these words, in here. I also have a link to feedback from Project 2 graphs that I've done in the past. That might help you a bit on things that can go wrong to make sure that you can not make those things happen. Okay, so very important. In terms of the timeline, let me get into this. Let me hit the syllabus again. Okay, so the project isn't due until June 25th. Okay, so you have some weeks, a bunch of weeks from now. Don't wait till the last minute. You're ready, actually. Okay, because now it's really about chapter 10. This is a chapter 10. Don't even think about doing anything from chapter 11, 12, or 13. Don't include any of that in your project. This is really about chapter 10, which is confidence intervals, hypothesis test for a population mean. It could be It could be, you could choose to be independent. You can choose to be dependent. That's your choice. Also, this is not project one, in that in project one, remember I told you had to use stratified sampling or you had to use cluster sampling. This one, you're allowed to use convenience sampling. Just admit to it. Admit to it and talk about the bias based on it. And no problem. Okay. So I don't take off points for using convenience sampling as long as you admit that that's what you used. So that's fine. The other thing about this project versus the other project, you had to do a survey of people. Do you remember that? This one, you have to collect data. You can use a survey of people, but you don't have to. And if you want to, you can literally just find data. If you can find the entire population's data, this project will not work. So it has to be a population that's so big or impossible to get to that you can't get the whole population. But you should be able to get to a sample. And the population needs to be much bigger than the sample. Okay, usually hundreds times bigger, millions times bigger. Could be at least 5 times bigger, but it needs to be a big population. And again, it doesn't have to be people. So for example, some people look at 2 different stores and compare the stores. Look at the prices or that type of thing. Okay, you can look at, I don't know, let's say you worked at a restaurant. You could look at percent tip at lunchtime versus percent tip at dinner time. Okay. And I don't know, maybe you think that people tip more at dinner time. I really don't know. I don't work in a restaurant, but do you see that would be a hypothesis? Okay. Some of the rules are the same. If you do ask people, and you remember who you're not allowed to ask. It's the same rule. Yeah. You're not allowed to ask minors. Okay. You're not allowed to ever ask anyone under 18 unless they are a college student at the college and you're asking at the college, then it's actually allowed. But otherwise, you're not allowed to go to a high school and ask high school kids. It is against the law. So don't even think about it. Got it? And the other thing, same rules before. If you, let's say, went into a store, let's say you went into, I don't know, Safeway Market and looked at prices. On that one, you probably even don't have to ask the manager. But if you ask people, you have to ask the manager. Okay, so if you're doing anything where you're surveying people in a store, make sure it's okay with the manager. They almost always say yes. If you're looking at prices, you don't even have to ask the manager because then you just look, you're allowed to do that. No manager is going to say you're not allowed to do that because that's allowed. Okay, you could also go online and look at stuff online and, say, I don't know, temperature in Tahoe versus temperature in Mammoth. I don't know. And you can go online and look at a bunch of temperatures, okay, for the high temperature or something. And that's fine too, because that's something you can't get every temperature that's ever happened. Do you see how that works? Okay. As long as you get a sample size of over 30 and you can't get all of them. Any questions about all this stuff so far? Okay, I like to do timeline backwards in reverse. Okay, so the absolute due date is June 25th. I recommend setting your brain to say the due date's the 24th. That way, if something goes wrong, you have an extra day and you don't lose points or get 0. So kind of plan, make sure you try and get it done by the 24th. Same rules before when it comes to the setting the ref draft. Is that has to be done by Thursday at 8 in the morning, but better is earlier. So if Sunday's the 25th, you might want to think about like the 20th or so to try and get it to me. And then I can take a look at it and I'll give you lots of feedback. Okay. And Adriana, oh, sorry, I can't say her name. I'm not, no kidding, there's no Adriana here. There's So I did do the secret word already. Secret word's in the webinar. Yeah, secret word is in the webinar. So hopefully you wrote it down, but I'll direct message you anyway. But I did do it. Yeah. That was in the webinar. That one, my memory's not that bad. So just to note, you want to get, like I would say like a Tuesday be a good goal to have the Tuesday before the due date to have the project done, rough draft done. And then I would say maybe within a week or maybe in a week or so to have your idea and post your idea on the project 2 discussion forum and post what your idea is. I'll let you know. And again, get help from the tutor. Kyle's always happy to help. And so are others, but Kyle's our #1 tutor. So those are the things that you can do. Okay. That's about it. That's about all I need to talk about, unless you have questions. So I think I am going to stop the recording.